Hi Chem 100 and welcome to the introduction video for Lab 2, which covers measurements. Now, I thought I would make the introduction to this video and for this lab and many of your other labs as a pre-made video to kind of give us a break from our Zooming, let you work on this on your own time. For this lab, we're going to be reviewing some of the skills that we already covered in class. But of course, if you ever have questions while you're looking at the introduction to a lab, just email me and hopefully I can get to you in a reasonable amount of time. So we're going to be talking about taking measurements in the lab. Now, is this ideal? No, of course, ideally we would be in the lab taking measurements. So what we're going to be doing is just taking a look at pictures of measurements and learning how to read measuring devices with the correct number of significant figures, reading with the correct precision. So we're going to go through this handout for the introduction. So let me pull that up. And this handout we're just going to go through, and then there's actually two handouts for this lab, one for the introduction and then one for collecting data, just to be very specific on where your data collection instructions are. So when we're looking at taking measurements in the lab, the thing we have to be really careful about is not just what number you're throwing down on your data table, but what precision you're using to record that data. It should match the precision of the instrument that you're using. So the rule that we use as chemists when we're using graduated devices, so that is any device where you're reading between lines, that is to take a look at the measuring device. What is the value of that smallest line? So if I'm going one line to the next, what value am I jumping up? Am I jumping up 1 centimeter, 1 milliliter? Am I jumping up 0.1? So that you have to do detective work. And then whatever you record, the reading from that can go 1 digit beyond whatever the value is of that graduation or that line. So when I'm talking about words like precision and accuracy, there is a slight difference between those two, and we're going to be looking at both of those. So precision is to what degree is the measuring device calibrated, and then accuracy is how close to a given value, a known value, are you able to get. So we're ideally looking for both precise and accurate readings when we're in the lab. So precision, are you reading to the correct number of significant figures? Accuracy, are you getting a number that is relatively close to what the value should be? Now, when we are taking our recordings, you also need to be keeping track of units. So that can change, but particularly when we're taking measurements in the lab, make sure that your units for mass are of mass units, so grams, milligrams. Your units of length should be in length units and be the correct length units. So in this lab, we're going to be practicing taking accurate and precise measurements. So to do that, we're just going to be doing some warm-up problems together, these class exercises. In a normal semester, we would have done these together. So we're just going to kind of do these together to make sure that you're feeling confident with the readings that you're going to take for the actual assignment. So in this first exercise, we're taking a look at a metric ruler, and we're going to be measuring the shaded in rectangle at the top. So the first thing is, when you're using a ruler, make sure that you have the end of whatever you're measuring lined up with the ruler wherever its measurements start. Now, some rulers, the measurements start at the very end of the ruler. Other types that are more old-fashioned, like the wooden ones where they get kind of curved off, those measurements will start a little bit inward. So you need to make sure that you're lining up your device and your object in the same place. So the first thing you should be asking yourself whenever you're taking a measurement is, to what level is my measuring device calibrated? So what is the value of the smallest division? Now on this ruler, let's take a look. My big lines are each worth 1. I see 1, 2, 3, 4. However, there are smaller divisions between those values. And there are, if I count it up, there are 10 divisions for every 1 centimeter. So that means, and let me get this so that I can write, that means that every line is worth 0.1 centimeter. So that means when I read the value for the length of this object, I can estimate to 2 places after the decimal. So it looks like we know it's between the 7 and the 8. So our first value is going to be 7. And then I can see it's between the point, here's 7.5, 6, 7, 8, and it looks like it's between 7.8 and 7.9. So we know 7.8 exactly. And we're going to estimate our next digit. I think it's exactly halfway between. So I'm going to say 7.85. If you're thinking it's a little closer to the 9 line, you could say 7.86, 7.87. With this lab and the Blackboard assignment, there are a range of values that are accepted for all of your measurements that are kind of fuzzy looking, and maybe to one person it might look a little closer to a line than another person, but you do have to record with the right number of significant figures. So your answers may be a little different from a classmate, but both might be acceptable. And then always put a space and then the unit. Okay. Now, if the width of this object was 0.66 centimeters, what would the area be? So for a rectangle, our area is equal to length times width. So we're going to multiply 7.85 centimeters, our length, times 0.66 centimeters. And that 0.66, that only has 2 significant figures. Remember that the zeros at the beginning of decimals, they do not count. So when we do this multiplication, we are only going to round. I get 5.181, and my unit would be centimeters squared. So I'm going to round to 2 significant figures, 5.2 centimeters squared. In your lab, you're also going to be calculating volume of a rectangular object. Volume is length times width times height. So let's move on. Let's talk about volume of a liquid in a graduated cylinder. So we're going to be using graduated cylinders quite a bit in this class. They're a very important measuring device to chemists. They're what we use to measure the volume of liquids. And when we measure the volume of a liquid, the curvature at the surface of that liquid, remember, is called a meniscus. So we're always going to read the very bottom of the meniscus. Now, what you're going to see is that when we get to real life measurements, that meniscus is not usually as clearly drawn as the picture we have here. So you do have to use your best judgment as to what is the bottom of that meniscus. Sometimes the meniscus is not a line, it's kind of a band of color, and you always just read the bottom of whatever you can see, okay? So when we are reading the volume of a liquid, one handy thing to note is that when we are reading in a graduated cylinder, that's milliliters, but 1 milliliter is equal to 1 centimeter cubed, and that'll come in handy in a few, in a number of ways, maybe not in this lab, but we will see where knowing that equation, knowing that those 2 units, a milliliter and a centimeter cubed, are the same, is going to be very handy. So let's take a look at our graduated cylinder we have here. And this looks like it's a 50 milliliter graduated cylinder. So the first thing I'm going to do is I'm going to take a look at what is the value of the smallest line on here. So I see 10, 20, 30, 40, but then there's lines between those. Those are the ones that we care about. And that is what it's asking, to what level is the graduated cylinder calibrated? It's saying, what is the value of the smallest line? Now, since I can count that every one is between 40 and 50, it's going 41, 42, 43. That means that this is calibrated to 1 milliliter, which means when we take our reading, we can actually express that to the next digit, which would be the 0.1 milliliter place. So when I read this, some of you may say that that is exactly on the 43 line. If that's the case, you would say 43 and then put a 0.0 to say it's exactly at that line. If you think that it's just below that line, and I kind of think that it's just below, we would write that as 42.9 milliliters. And both of those answers would be acceptable if this were, say, a lab problem or an exam problem. I would have a range of acceptable answers, but all of those answers would have one digit beyond the decimal. If we were to express that in centimeter cubed instead of milliliters, it would be the same number. So if we were using the 43.0 centimeter cubed, it's just the same thing. Or 42.9 centimeter cubed. Now let's take a look at a smaller graduated cylinder. What you're going to see is we'll see examples in our labs of different sizes of graduated cylinders. And the smaller the graduated cylinder, the easier it is to read. You'll see with this picture that that even though it's a simulated meniscus, it is an easier to read meniscus, and that is accurate to real graduated cylinders as well. I find the smaller ones much easier to read than the bigger ones. It has a more defined meniscus. So let's take a look at this one. I want you to take a moment and determine what level is this graduated cylinder calibrated. So what is the value of each of those small lines? I see that there's big lines at 4, 5, and 6. So that must mean that the smaller lines, those are worth 0.1 milliliter, which means for this volume, we can actually estimate to 2 places after the decimal. So I can see that is between the 5.4 and the 5.5 line. So we know exactly that it is 5.4. This next digit and the last digit is the one that we are going to estimate, and it may be different between you and me. I think it looks like it's about halfway, maybe a little more. So I'm going to say 5.46 milliliters. If you said 5.45 milliliters, that's fine too. Let's talk about mass. So in this class, all masses are going to be taken using an electronic balance. And the great thing about electronic balances is that there is no brain work when you read these. All the digits on the display are to be recorded. Even though the last one is uncertain, it can waver a little bit, often due to air currents, but that's okay. You're going to record everything. Never round with an electronic balance. Sometimes students like to round because they think it's too easy just to record everything. Not everything in chemistry is super hard, so don't overthink it, just record everything. So for this one, if your balance is telling you 173.865, it's 173.865. We just need to add that unit, and that's always going to be grams. So when we're using an electronic balance in the lab, it's always in grams. And the last type of measurement that we're going to be taking in this lab is temperature. Chemists use the degrees Celsius unit for temperature. And what temperature measures is the average movement or average kinetic energy of the particles. How much are they moving? So for this particular temperature, let's take a look at what its calibration level is. What is each line worth? We see 30, 35, 40, which means each little line is worth 1. So each line is worth 1 degrees Celsius. That means we can estimate 1 digit beyond that. So we can estimate to 1 place beyond the decimal. So to me, it looks like it's between the 34 and the 35, which means we know for certain the 34. We're going to add 1 more digit, which is our uncertain digit, and that's going to be our estimated one. I think it looks like it's about halfway between, so 34.5. And then our unit is going to be a degree symbol and then a capital C for Celsius. So for each of your exercises within the lab assignment for lab 2, you're going to be practicing these skills. Here, let me stop that share. So you're going to be practicing these skills. For every time you're looking at something with lines, make sure you determine first what the value of the smallest line is, and then estimate 1 digit beyond that. Good luck, and we'll talk about it in lab class if you have any questions or if you want me to go through any more examples. I hope it goes well.